The title of this lesson is Numerical Measures and Graphical Displays of Univariate Data. So in the last video, we introduced our variables. Let's look at the Raw Data tab. In the Raw Data tab, here are the variables. So like here's a pitch that came in from the mound by a Major League Baseball pitcher. From the windup, it was pitch location 11. Let me look at pitch location 11. So it was here. It was a strike, and the speed was 92 miles an hour. And so we have lots of rows of data. I think 840. Yes, 840, but we have a variable name row. So we have 839 rows of data, each row corresponding to a pitch. We're going to study one variable at a time. Later, we need to study how do each of these variables relate to speed. How does the stretch or wind-up variable relate to speed would be one of the main questions of interest. But for now, we're just going to work on studying one variable at a time. We want to get good at that before we start combining. So that's why this is called univariate data analysis, one at a time. And let's start with speed. So I'm going to highlight E and Control, and I'm going to paste E into the Analyzing Speed tab. All right, so in this video, we're going to analyze speed using some numerical measures. So numbers that have some sort of measurement of the data, and we'll talk about what that means. And then in another video, we'll talk about some graphical displays of the data. So one of the first things that you'd like to know about a data set is what is the center of the data? And the center of the data is very commonly computed by the mean, also known as the average. Now, the mean is not always a good measure of center, and we're going to talk about that later. But for now, let's just say, how do you find the value? And so we're going to equal, I type mean, but there is no mean because Excel calls it average. So we're going to find the average of, and we want column A. And Excel knows that since there's a non-numeric variable, a value there in that cell, to ignore that. And so we have that the average, on average, if you add them all up and divide by how many there are, the average speed of the pitches in our entire data set is 75.66. Now, of course, I'm going to take this down to 2 decimal points. Of course, what we're really interested in is what is the average speed for the windup versus the average speed from the stretch. But we're going to deal with that later. Right now, we're just going to concentrate on the whole of analyzing. Out of all our data, the average speed is 75.66. Okay, what is so that's if you take everybody and we add them up and divide by how many there are. Now the median is another measure of center, and it captures the middle. What's the middle of the data? If you lined up all the data and found what's in the middle, so that's the median of column A. And we see that it's very close. And so what we have is, we know the average and middle number are very close. Okay. Now another measure, I should say this is the measure of center. Another measure of the center of a data set would be the mode. The mode is what happens most often. And so the mode of this data set would be, which number happens the most often? 93. That's interesting. And so The average and the middle number are both close to 75, but the value that occurs most often is 93. We expect that this data set is not symmetric. It has some high values up at the top. It looks like at least there's some sort of spike in the 90s, with the general center around 75. So we expect that when we draw a graph, there's going to be some sort of spike. Okay, now those are measures of center. What if we wanted to measure well, the maximum value? So the biggest value is going to be 96. Wow, so the maximum is 96, but the most common is 93. Interesting. We really want to get into this data set more. The minimum is 37. So you see how there's only a little bit of space between the max and the most common value. That's interesting. And there's a large space here between the median and the min. Between the median and the max, it's like 20, but between the median and the min, it's way more than 20. So I expect sort of a peak at top and spread out slowly towards the smaller speeds, because it really takes a while to capture the bottom half. Now, the quartiles break up the data into 4 parts. So let's start with the first quartile. So if you type quartile, okay, we will look at the quartile of the column A, and we want the first quartile, the 25th percentile. And that is 70. The first quartile is bigger than 25% of the data. So 25% of the speeds are less than 70 miles per hour. Whereas for the third quartile, that's bigger than 3/4 of the data. So if we go for the third quartile, okay, then we have that the third quartile is bigger than 3/4 of the data. So 75% of the speeds are less than 80 miles per hour. Of course, with the median right in the middle, that's 50%. 50% of the speeds are less than 75%, 75 miles per hour. And so we see that there seems to be quite a bit of symmetry here in the middle, but it's just there's this spike at the top and it spreads out in the lower part, I think. Okay, we're going to talk about the rest of these things in the next video.